Thank you. I'm Mr. Lehner and welcome back to Mr. Lehner's Math Extravaganza. Yes, my beard is getting itchy, and yes, this tie is a little out of season, but that's alright because there's still a lot of snow on the ground. Today's webisode, we're going to take a look at surface area and volume, and we're going to focus on making boxes with that. So I guess this kind of all does fit together in the season of maybe giving gifts with some boxes, with some snow, the beard, the tie. Okay. Surface area of a box though. Basically how you're going to find the surface area is you're going to count each of the area of each of the faces of the box. And again, we're going to be looking at some 3D shapes, so each one of the sides or the faces of that figure. And then when we're finding the volume, or how much something can hold, we're going to multiply the length times the width times the height. And that's going to tell us how much that box, in this case, can hold. And we're going to start off with some flat shapes that look just like this. And we're going to find the surface area of each one of these. We're also going to find the volume of each one of these. And yes, as I'm sure you could have guessed, I'm going to do one and you're going to do one. Alright, let's take a look underneath our document camera to kind of show you these as flat shapes. And we're going to find both the surface area and our volume. Okay, so we're going to start with box P. Okay, so when looking at this box flat, well, it's not a box, is it? It's just a flat, one-dimensional figure which I'm going to eventually turn into a nice 3D shape. Now you might be asking, when do I need to know this, or how am I going to use this? Well, think of like the post office. If you're going to send a package to somebody, people in the post office will take these designs and create a box to fit a certain type of item that needs to be sent, say to a friend that you're sending it to. So we're going to take a look at this box here. We're going to call this box P. Now, to save time, I've kind of already cut these out into it. But I have to kind of figure out where can I make folds on this figure to create a 3D shape. So, as I look at this, one of the things I notice about this figure is that this top here and this bottom here might be like the top and the bottom of the figure. So if I start to fold, and I make a fold like this on the top part in, and then I fold this bottom part in like this, I now have the two parts on the sides, or I should say the top and the bottom. So I might decide, you know what, I'm going to try and fold it on each one of these into a column. So if I make a fold here, I make a fold on this side, I make a fold here on the third side, and I put them all together, I now have a 3D figure. Again, this was our box. So there's their side, there's the other side, there's another side, there's the top, there's the bottom, and there's another side to it. So I just took this figure, box P, that was a one-dimensional shape, making some folds here on the side. I've now created my 3D box to hold an item. Now, I don't know about you, but when I look at this item here, I think of like a package of like a Tootsie Roll, or like Roll-Those, which we've talked about in here. Like a package of those, this might be like a good candy dispenser. Now, looking at this box with my 3D shape, I'm going to find the volume, and I'm also going to find the surface area. And here's how we're going to do that. I said for surface area we need to count all the faces. Well, this is one face. I know that there's 1, 2, 3, 4, 5, 6. This side has 6 on the side. So this is going to be 6. On top is going to be another 6 is 12. On the back here is another 6, which is 18. On the bottom, another 6, which is 24, 25, and then 26. So I know the surface area of this figure is going to be 26. And again, we would add in our units of measure, whether we're working with centimeter, inches, meters, however we're going to decide to do that, you would add in your unit. So it has a surface area of 26. Now to find volume, how much can this box hold? What can I fit inside of this box? I'm going to use our formula of length times width times height. So the length, how long is this? It's 6. What's the width? The width is only 1. It's going across 1. And how tall is it? It's up 1. So length 6 times the width, which is 1, times the height, which is 1, is going to give me a volume of 6 cubic feet. So I can fit, or I put feet in here, but say 6 cubic inches. I'm getting tongue twisted over here. but 6 cubic inches. So you'd see that 3 above the top there. That tells me that's how much cubic inches I could fit inside this container here. So again, if I wanted to use this box to figure out, well, how much or what can I fit in here and how much can I fit in here, the volume would be 6 cubic inches is what I can find in here. And again, I simply started off with a simple one-dimensional figure. I made some folds, and we turned this bad boy into a nice little 3D package. Okay, here's what you're going to do. I did box P. We found the surface area and the value. You are going to do, there we go, perfect. You are going to do box R. I like that. It looks just like a T. You know, maybe T for Tommy or something like that. Who knows? I like that letter. But what you're going to do is you're going to recreate this box at home. So you have grid paper you can draw this out on, or if you just want to draw it in a piece of plain paper and then label out your boxes. But make sure that you draw the boxes so that they are all the same length. That's why I say I think grid paper would be your best bet to use. But go ahead, I'd like you to find the surface area and the volume, making this one-dimensional figure into a 3D figure. Go ahead and pause that video. We'll see what you come up with. Alright, box R. Now this one can be a little bit tricky. We started off with the T looking just like this. Now you kind of have to mess around with these a little bit sometimes to figure out how can I turn this into a box. Now, what you could have done here on the sides is decided to make each one of these into 2s and fold on each 2. So, started with the box, folded these 2 together, folded the next 2 lines, folded the next 2 lines on the side here. So if I can get this to stick. And then I had the 2 flaps on the side. Well, the 2 flaps on the side I can fold in, and now I've just made my box. Try to do my best to hold it together. But here is now the box. And again, we're going to try and find the surface area, and we're going to try and find the volume of what this 3-dimensional figure can hold. Now, with surface area, I told you guys we had to count the faces for the box. Well, I'm going to count my squares because we have nice grid paper to help us out. I see 2, 4, 6, 8 on top. That's just one face though. So 8, another 8 is 16, another 8 on the bottom is 30, no, another 8 would be 24. Another 8 on the back here would be 32. Then 4 on the side is 36. And another 4 on this side would be 40. So the surface area of this is going to be 40, based off of all the faces of this 3-dimensional figure. Remember, when you're counting these, do not forget to count all sides of your box, all the faces that are on there. Okay? Let's take a look at the volume. For our volume of this figure, when looking at it, as I look across, this one's a little bit different. But the length, how long is this figure? 1, 2, 3, 4. It has a length of 4. What's the width? 2. It's 2 across. And then how tall is it? It's 2, its height is 2. So I'm going to multiply 4 times 2, because that's length times width, which is 8. And then times the height, which is 2. So 8 times 2 would be 16. So I can fit 16 cubic inches into this box, say if I was going to send it, again, to a friend. Now, another way to think about this is each one of these makes a cube. If I was going to fit these cubes in here, I can fit 1, 2, 3, 4, 4 on here, and another 4 up here. So 4 and 4 would be 8, right? Then I could fit 4 on this side, and 4 here on the back side. So if you're a visual learner like I am sometimes, I might take some cubes and pretend how many cubes can I fit inside this figure to find the volume. I'd be able to fit 16 cubes, which is 16 cubic inches inside this figure. Thank you for tuning into a tongue-twisted adventure here on Mr. Lerner's Math Extravaganza with surface and volume. And as always, we'll see you next time.